The folks at Bell Labs and Nippon Telegraph and Telephone were the pioneers of DWDM technology. In 1996, Ciena Corporation launched the first commercial DWDM system for Sprint's long-distance network. Now defunct companies Lucent Technologies, which was spun off from AT&T Bell Labs, and Canadian company Nortel were also key players in the DWDM scene in the 1990s. Today, DWDM forms the spine of the internet by multiplying the capacity of existing fiber optic cables. With DWDM, hundreds of data streams can coexist in a single fiber cable, enabling terabits per second speeds. The advancements in technologies have lessened the need to install more fiber cables, which cuts costs and reduces the need for physical infrastructure. It has made streaming, cloud computing, and real-time services possible by moving large amounts of data across countries and oceans. Huawei Technologies is the biggest of the Chinese equipment providers. Headquartered in Shenzhen, China, it was founded in 1987 as a privately held company owned primarily by its employees through a unique stock-sharing model. But despite its private status, it faces global scrutiny over perceived ties to the Chinese government. Huawei began by manufacturing phone switches. It expanded globally in the 2000s with telecom equipment like base stations. By 2010s, it had begun to dominate 5G patents and infrastructure. In 2019, US sanctions crippled its smartphone business with chip restrictions and software bans. Market share fell by 18% in 2019 to about 4% by 2023. The Americans labeled them a security threat and convinced their allies from Europe, Australia, and Japan to ditch all Huawei telecoms equipment as a precaution from Chinese spying through backdoors in Huawei equipment. But even after all that, Huawei rebounded and is now the world's largest telecoms equipment vendor, a global tech titan that produces not only telecoms infrastructure like 4G, 5G equipment, optical networks, base stations, but also smartphones, laptops, semiconductor carrying AI chips, and now even cars. Huawei today innovates aggressively in semiconductor chips, 6G technologies, AI, and EV cars to offset sanctions. It commands about 35% of the global telecoms infrastructure market and leads in 5G deployment. It operates in more than 170 countries, mainly Belt and Road nations, with strongholds in Asia, Africa, and Latin America. Its DWDM is the Optics OSN 1800 OTN platform used for metro, subsea, and backbone networks. ZTE Corporation is the second biggest Chinese telecom supplier. It is a state-owned company founded in 1985, headquartered in Shenzhen, China. It expanded globally in the 2000s, becoming Huawei's biggest competitor from China. In 2018, it faced US sanctions for violating Iran-North Korea trade restrictions, resulting in a $1.4 billion fine. Like Huawei, it is also known for a wide range of products including smartphones, 5G telecoms base stations, etc. In China, it holds about 10% of the telecoms infrastructure market, trailing Huawei's 30%. It is also a minor player in smartphones with about 5% share against giants like Xiaomi and Oppo. Globally, it has a market share of about 10% in the telecoms infrastructure, fourth globally after Huawei, Ericsson, and Nokia. It operates in about 160 countries with strongholds in Asia, Africa, Europe, and Latin America. Its key DWDM product is the ZXZone 8000 series for ultra-high capacity fiber transmission. Headquartered in Wuhan, China, FiberHome is another Chinese state-backed company with expertise in telecom networking and 5G-ready solutions. It pioneered China's first optical fiber in 1982 and became an integral part of connecting China. Founded in 1974 as a research institute, FiberHome evolved into a telecoms giant, driving China's optical network expansion. Today, it competes with Huawei and ZTE in domestic and global markets. Key projects include the P submarine cable connecting Asia to Africa and Europe. FiberHome designs and manufactures telecom systems like base stations, fiber optic cables, and DWDMs. It has presence in more than 50 countries around the world, positioning itself as a cost-effective alternative to Western vendors in emerging markets. In China, it holds about 20% share in optical networking, supplying major carriers like China Mobile and China Telecom. It exports to about 100+ countries, focusing on Asian countries like Pakistan, Indonesia, African countries like Nigeria, Kenya, Latin American countries like Brazil, Peru, and a few European countries. Globally, it competes with Huawei, Nokia, and Ciena, but holds a smaller market share about 5% in optical systems. Its key DWDM product is the Phones series for long-haul and metro networks. DWDMs come with special features. Let's explain some of these features. ROAD-M stands for Reconfigurable Optical Add-Drop Multiplexer. This feature allows wavelengths to be added, dropped, or routed on-site, making the system more reconfigurable and enabling network operators to remotely provision network traffic. FlexGrid. This feature enables variable channel spacing of wavelengths for more efficient spectrum use. FlexGrid is now mandatory for 800G and 1.6 TB networks. Proprietary DSP chips. Some DWDMs are powered by in-house designed custom chips that facilitate higher transmission speeds. Ciena's exclusive digital signal processor chipset is called the WaveLogic DSP. Nokia's is the PSE6 and Huawei is ODSP. IP over DWDM. IP over DWDM integrates IP routing within the optical layer. Ciena calls its version adaptive IP, with Huawei calling its version OptiTrans OTN switching. Comparing DWDMs from public information is difficult, but units from Huawei, Ciena, Nokia, T8 and ZTE all seem to have top wavelength capacity of 800 GB per second per wavelength. The units from China's FiberHome and Indian manufacturers Tejas and UTL have less wavelength capacities at 400 GB per second. Huawei has a model with the highest number of channels at 120, and the rest of the companies have units of up to 96 channels. The maximum throughput for units of Ciena, Huawei, T8, ZTE is around 38.4 terabits per second. Most operators seem to regard Huawei and Ciena's offering the best balance between capacity and programmability, while Nokia provides the most flexibility and reconfigurability, good for metro, regional, and core networks. DWDM sits at the foundation of today's networks. It powers the physical layer that carries all the data for upper layer protocols like IP, Ethernet, and OTN. By enabling terabit scale data transport over existing fibers, it ensures seamless connectivity to everything from telecom operators to global cloud service providers. DWDM allowed internet to grow exponentially without the need for constant digging for new fiber lines. Today, DWDM systems underpin AI searches, 8K video streaming, and virtual reality by delivering petabit level capacity. The first DWDMs that appeared in the 1990s transferred up to 1 terabit per second. The 2010s with coherent optics transferred 20 terabits per second per fiber, and the 2020s with special division multiplexing SDM is transferring about 100 terabits per second per fiber. Ciena will soon be introducing the next generation of DWDMs, moving from 800G to 1.6 terabits per second per wavelength. A new company, Mavel, has introduced a 3nm Mavel Ayar chip that supports 1.6 terabits per second, offering higher performance whilst reducing power consumption. In the near future, companies like Ayar Labs with optical I/O chips are merging photonics and semiconductors to offload some of the functions of photonic processors, thus increasing speed. Intel is also creating silicon photonic transceivers by integrating CMOS with photonic integrated circuits. DWDM will remain the backbone of global connectivity, evolving with innovations like photonic integrated circuits and machine learning-driven network optimization. Its creation marked a turning point in telecommunications, making the modern internet economically and technically feasible.